After looking at these pictures, I'm pretty sure you'll be convinced why a good design matters when implementing a project. From high-tech websites, gadgets, accessories, and cars, design plays a crucial role. So why not apply the design principle to programming? A good program design is going to save a lot of time and effort for you. I'd like to share an abridged version of a popular joke in software engineering community. The first phase of software development is gathering the requirements from a customer. Let's say this is what you as a programmer interpreted the customer's requirements. You write the code and let the business team describe it to the customer. Then you create documentation, bill the customer, and do the much needed marketing. But it actually turns out this is what the customer really needed. For this course, your customer is the instructor team. We will do a better job in asking what exactly we need in your homework submission. Okay? Once you understand the tasks you need to perform, you break down the task into a series of tangible steps. If you did that, you basically drafted an algorithm. An algorithm is a set of well-defined logical steps that must be taken to perform a given task. The next step of program design involves writing a pseudocode, a fake code in which no syntax rules are actually followed. Typically, programmers write pseudocode in the editor as comments. In Python, you can write a comment by beginning it with a hash character. When a Python interpreter sees a hash character, it ignores everything from that character to the end of the line. The pseudocode I've written here is for a program that takes radius as input, computes area of the circle, and displays it. Comments are also used as a documentation for your program. Typically, the author info as well as the program description are written at the top of the program. You are required to do the same in all of your homework submissions. Sometimes programmers also use flowcharts while designing a program. A flowchart is a diagram that graphically depicts the steps that take place in a program. The ovals are reserved for starting and ending points of the program. Parallelograms are used for input and output tasks. And finally, rectangles are used for tasks that involve processing. All these shapes are connected with arrows, showing the flow of the program. For this course, you just have to understand a flowchart when you see one. You need not draw them for the homework assignments. Alright, now is the time to introduce you to the program development cycle. Now that we have a design backed by the supporting pseudocode as comments, we venture out into the editor and start writing the code. Regardless of how much programming experience we have, we tend to make few mistakes with syntax. Remember the last time you made a typo texting your friends? Yeah. Once you identify all the syntax errors in your code and correct them, it is time to test your code. It might be possible that you made a mistake while translating a formula into code. This is a logic error. These errors are difficult to catch if you are writing a lengthy, complex program. Integrated development environments are often packed with a debugger that assists you in debugging your code. Yes, errors in programs are called bugs. Here is a picture of a moth that caused malfunction in Harvard Mark II Icon calculator. The team of programmers of this machine included Grace Hopper, who is a pioneer of computer programming. In 1947, the late shift team members left the window open at night and the moth met its end. The first computer bug was, in fact, a literal bug. Alright, now here is a quick summary of program development cycle. First, you design the program and then you start to write the code. You keep correcting syntax errors when they show up and make your code syntax error free. Then you execute and test your program to see if it works as expected. If yes, you made it. Else, check for logic errors. If they are minor, just edit the code and test again. If the logic error is major, it might require that you redesign the whole program and write code from scratch. You will eventually write a fully functional program if you follow this cycle.